Alright, so in this video, I'll be deriving the quadratic formula from the basic form ax squared plus bx plus c equals 0. Now, the quadratic formula is used to find the zero or roots of the equation ax squared plus bx plus c equals 0. So basically, it finds when this equation is equal to 0 on a graph. Now, to derive the quadratic equation, or the quadratic formula, we start with the quadratic equation, which is ax squared plus bx plus c equals 0. So to start off, we'll bring c over to the right side of the equation. So this will turn this into ax squared plus bx equals negative c. Now we'll divide everything by a. This will give us x squared plus x times b over a equals negative c over a. If we look at this geometrically, we'll see that we have a square with side lengths x plus a rectangle, or in some cases a square, with one side length x and the other side length b over a. And these combined equal a geometric shape which has area negative c over a. If we're to divide this shape down the side length b over a and combine it to our x squared box, we'll get a figure that looks kind of like this. A square with two side lengths. So this is x, and this is side length b over 2a and b over 2a, because these are half of what we had before. So one of these is equal to one of this. Now, if you'll notice, the new geometric shape that we created is missing an area right here. And to make this a perfect square, we're going to add this area to our equation. This area right here is actually equal to b over a squared, or 2b over a squared, sorry. And if we simplify this, it's b squared over 4a squared. Since we're adding a fictional part, or a fictional area, to our geometric shape, we have to add it to both sides of the equation. So before, we had x squared plus x times b over a equals negative c over a. So since we're adding this, we have to add it to both parts of the equation. And that's what we're left with. Now you'll notice this part of the equation is factorable, and if we factor it, we'll get x plus b over 2a squared. If we subtract these two terms, so we multiply this side by 4a, we'll get that b squared subtract 4ac is over 4a squared. Now we want to take the square off this, so we'll square root both sides of the equation. X plus b over 2a equals plus or minus the square root of b squared subtract 4ac over 4a squared. Now let's look at this part of the equation, the right hand side of the equation. This can also be viewed as plus or minus the square root of b squared subtract 4ac times 1 over 4a squared, which is the bottom part of our fraction here. If we expand this out, we get that plus or minus the square root of b squared subtract 4ac is divided by, so we divide the bottom part and the top part, 1 divided by, or 1, the square root of 1 is 1, the square root of 4 is 2, and the square root of a squared is a. So we bring that all out. we'll get 2a. So now we're left with, if we bring this back up, x plus b over 2a equals plus or minus the square root of b squared, subtract 4ac, divided by 2a. So now we're solving for x, so we want to subtract b over 2a from both sides of the equation. So x is equal to plus or minus the square root of b squared, subtract 4ac, divided by 2a, subtract b over 2a. If we subtract these two terms, we'll see that x is equal to negative b plus or minus the square root of b squared, subtract 4ac, divided by 2a, which if we look at our first sheet, we'll see is equal to the quadratic equation. So this equation can be used to solve for the zeros or the roots of a quadratic formula.